Howdy, seventh grade. Today we're going to talk a little bit about the probability of dependent events. And what that means is we're going to look at the probability of events that affect each other. So in the past, we've done independent events where you can do one thing and another, and the outcome of one doesn't affect what's going to happen for the second. And what that means is for an independent event, let me write that down. It's like flipping a coin. We can get whatever we want on the first flip, and then the second flip doesn't really care what we got on the first one. So events don't affect each other. The flip side of that would be dependent events, which is what we're looking at today. And that is when events do affect each other. That's not how to spell that. Events do affect each other. Awesome. So that's what we're looking at today, is the kind of events where what happens the first time is going to affect what happens the second. And a keyword for dependent events, what to look for is without replacement. So we want to look for without replacement. That's going to give us a little bit of a clue that what we're doing is a dependent event, and I'll show you an example of that. So the example I want to talk about first is that I have students in a class, 30 people total in the class. There's 18 girls and 20 boys. So we're going to start with an example. There's 18 girls and 12 boys. And I want to pick one student and then pick another. So pick one student, then another. And I want to know what is the probability both will be girls. And this is just a little shorthand we use where we do the P and the parentheses. That means probability of. So I'm asking, what is the probability they'll both be girls? Well, the probability of the first one's a girl is pretty simple. And we're just going to have to figure out, if I pick them randomly, there's a total of 18 girls and a total of 30 students in the class. So we're going to start with the probability the first is a girl, and that is going to be 18 out of 30, because this right here is the number of girls we have, and this right here is the total number of people in the class. So I have the probability that the first is a girl, and now I just need to figure out the probability the second is a girl. So what I want to do now is pretend that the first one worked out. So I have to first imagine that the first is a girl, and then think about who all's left. So now I don't have 30 students anymore to pick from. I only have 29. And if the first one I picked was a girl, then I only have 17 girls left in the classroom. So it would be 17 out of 29. Once I am done with that, I can multiply those together, and I get 18 out of 30 times 17 over 29 equals, and that would be, let's see, 306 over 870, which would give me, after simplifying, 51 over 145. So this right here would be the probability that if I picked two girls at random from that class, or sorry, two students at random from that class, they would both be girls. Another way we can write that, so some notation. Notation, of course, being how we write things, is that if I have the probability of picking a girl given that the first is already a girl, a way I would write that, it would be probability of girl given that girl has been picked. So this line right here means given. So assuming the second part has already happened, what's the probability the first has? Let me write that down. So looking at this parentheses, what it really means is that assuming a girl's already been picked, or given that a girl's already been picked, what is the probability, this P again, that we're going to pick a girl? So we can continue with this and look at another couple problems. If I have 20 computers that I am shipping out to different people, I am part of a manufacturing company, and I am shipping out 20 computers. And 3 are broke. But good news, I'm going to test my computers before I send them out. So if I randomly select and test them, I want to test 3 of them. I want to know what is the probability that those first 3 that I pick are the 3 defective ones. So what's the probability that first 3 I pick are broken? So to do that, we are going to start by saying, well, there's 20 computers, and I have 3 of them that are broken. So for my first pick, I have 3 out of 20. That's the probability of having 1 broken. Now, after I picked that, my probabilities changed a little bit. So I'm going to have to now multiply by, there's only 2 broken left. So that would be 2 out of 19. After I get that one, there's only 1 broken left, which would be 1 out of 18. And I need all 3 of these things to happen in order for me to pick the 3 broken computers in a row. So let's do some quick math. 3 times 2. I'm actually going to cancel some of these out. So I have a 2 on top and a 20 on bottom. That's the same as 1 over 10. I have a 3 on top and an 18 on bottom. That's the same as 1 over 6. So now I have 1 over 6 times 10 times 19. 1 over 60 times 19. 60 times 19 is the same as 60 times 10 plus 60 times 9. That'd be 600 plus 540, or 1,140. So 1 over 1,140. And just like that, we know the probability of finding my 3 broken computers, the first 3 in a row out of a set of 20. So not very likely there. It looks like I'm probably going to have to look a little bit harder than that. But I have a 1 out of 1,140 chance of it working, so I guess that's all right. I also, just random note, have a 1 out of 1,140 chance of them being the last 3 computers I look at, which would be a real shame. So in any case, a quick reminder of what we learned was some notation. We have probability of A given B means, let me write that down. It means the probability of A given that B has already happened. And sometimes this is also written as probability of A comma B. That's the same thing. In any case, I will see y'all in class tomorrow, and have a great day.